Good day everyone, we're going to provide solution to this given questions. So question 1, we need to show that summation I from 1 to n 3i minus 5 equals n over 2 then 3n minus 7. Okay, so to do this solution, so given that I told you the other time in the last class that this sign is called sigma, so we have I from 1 to n and we have 3i then minus 5. So we need to show that the whole of this will give us what? N over 2 then 3n minus 7. Okay, so from left hand side now, so that's where we have to start from, because whenever you ask to prove, okay, you need to start from one of the sides. Okay, is that from left hand side or right hand side? But in this case, you need to start from where? From left hand side. All right, so and what do we have there? We have I from 1 to n then 3i minus 5. Okay, so for you to solve this, you need to watch my previous video I did on this particular topic. I told you when you have something like this, the first thing to do is to split what you have here, and where this can be written as I equals 1 to n then 3i then minus I equals 1 to n then you have 5. Okay, and don't forget this 3 here is constant, which that can be factorized out here, meaning that you cannot write that as 3 summation I equals 1 to n then I then minus n then I equals 1 to n then you have 5. Okay, so don't forget I've given you formula for this before, where the formula is given to be summation I from 1 to n. The formula is given to be n over 2 then n plus 1, and of course there is proof for this, but this tutorial is not meant for that. All right, but if you want me to prove that, you can actually drop that at the comment section to know if I'm going to work on that in subsequent videos. All right, yeah, so from here now, so we need to replace what you have here now with this, so meaning that you're gonna have 3n n plus 1 over 2. Okay, so this is constant term, and this implies that you are going to have, you multiply 5 in n places. You understand? If multiply, you take sum of what? 5 in n places. You understand what I'm saying? So because this 5 here is constant, so and for us to have that now, I told you this is going to be 5n. Okay, so the next thing is to take your LCM. So you have 3n then n plus 1 then minus 2 times this, you have 10n. You have 10n. Okay, so this is 2. So this is gonna give us what? You can factorize out n. Okay, or it depends, let's factorize n, then we're gonna have 3n plus 3 then minus 10, okay, over 2. So you have n then 3n minus 10, that's minus 7 then over 2. And let's see if what you obtain here is same as what you need to prove, as you can see, and that is the proof of the given question. Okay, so let's consider the second question. Question 2, we need to determine the value of 1 minus 2 plus 3 minus 4, and this process continues. Then second to the last time, we have that to be 2n minus 1 then minus 2n. So when you look at this is just like sum of consecutive natural numbers. Okay, but the only difference here is that the sign here alternates, so which implies that the odd number takes positive while even number takes negative. You understand? As you can see now, we have minus 2 here, minus 4, minus 2n. So all these are even numbers. Okay, while odd numbers here are 1, 3, 5 then onto 2n minus 1. Okay, so the best way, we have different method of solving this, but I think the best way to go about this is to separate even numbers from odd numbers. You get it? So from here, Now we're gonna have 1 plus 3 plus 5 plus 7. Then the process continues, and the last term we can have for even number, for odd number, so that would be 2n minus 1. Okay, now let's consider even numbers now, and we all know that for even number here takes negative, so meaning that we can actually factorize 2 minus out here. Then we're gonna have 2 plus 4 plus 6, so the process continues, where the last term there will be what? 2n. Is that taken now? Okay. And when you consider the last term of each of these numbers, the even numbers and the odd numbers, for that of odd number you have 2n minus 1, which implies that this last number represents this is the AP of the series. Okay, because when n is 1, if you put n to be 1 here, you're gonna have 1. When n is 2, you're gonna have 3. When n is 4, you're gonna have 4. You're gonna have 5, like that. So the same thing applicable to 2n here. When n is 1, you have 2. When n is 2, if you put 2 here, you have 4. When n is 3, you have 6. So which implies that the last term of each of these numbers represents the series. You get it now? So now we can now write this now to be summation I from 1 to n. Then you're gonna have 2i minus 1. So you are not going to use n here again now, because we are representing this in terms of I to n. Okay, so then minus, this can be written as I equals 1 to n. Then you have what? 2i. All you need to do is to consider last term of each of the series. Okay, now so we can split this, and this can be written as I from 1 to n, 2i minus I from 1 to n. Then you have 1, then minus I equals 1 to n, then 2i. Okay, so and of course, looking at this now, it is obvious here that what you have here is same thing as this, and that will cancel out because they have opposite sign. So what will you left with? You left with minus summation I from 1 to n1. Okay, and what this means is you are going to take sum of 1 in n places, so which is minus n. So this is the solution to the given series. So the sum of these values now will give us what? Minus n. So you can